Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, this is video 3 in the playlist where we're looking at the Edexcel November 2018 higher tier paper 1. In the previous video we completed through to question number 12, so from this video we're going to start looking at question number 13 onwards. Please do stop the video, have a go at each of the questions and then compare your solutions. Okay, so this one is hopefully a relatively straightforward single transformation. Now what they're asking is, what is the transformation that maps A onto B? And it's a single transformation. So what we're going to do firstly is have a look at the lines of enlargement, and hopefully that'll give us some idea of the center. Okay, so if you draw a line using a ruler from each of the tips, what you'll find is that they will cross at a specific point. Okay, so I'm just going to draw these. I appreciate it's not going to come across too brilliantly on the video, but hopefully it'll give you some idea. Okay, so corner to corner there is going to be something like this one. Okay, so what we've got now is a transformation that maps through the point 2, 2, and it's an enlargement from A to B of -1/3. So it's actually, this is 3 units. The same line, the other side is going to be 1 unit, so it's -1/3. And I'll just kind of write that on here. Again, if you're not sure about any of these things, just please add a comment below on the channel or on the video, and I should be able to give you a playlist that will explain these things in a bit more detail. So it's an enlargement of -1/3 through the point 2, 2. Okay, hope that's okay for you. Let's move on to the second one, which is a fractional indice. This is question number 14. Again, please do stop the video, have a go at this question. Okay, so work through the value of 16 over 81 to the power of 3/4. Okay, so there is a technique really for dealing with these, and that is to actually separate the 3 from the quarter. Hopefully this will make sense if I write out that what I'm actually going to do is 16 over 81 to the power of 1/4 cubed. Okay, because 3 times a quarter is 3/4. Okay, so this 1/4 basically means the 4th root of each of these numbers. So it's a bit like when we say something to the power of a half, we really mean the square root, or to the power of a third is the cube root. So this one is the 4th root. Well, the 4th root of 16 is going to be 2, because 2 times 2 times 2 times 2 is 16. In a similar way, 81 is 3, because 3 times 3 times 3 times 3 is also 81. Okay, so that will deal with this center piece here, and then we've got to cube each of these numbers. So what we're going to end up with is 2 cubed is going to be 8, and 3 cubed is going to be 27. So the value is going to be 8/27. Okay, hope that's okay for you. Let's move on then to question B, or part B of this. And it says, work out the value of A plus B plus C. Okay, so let's have a look at each of these in turn. So 3 to the power of A equals 1/9. Well, all that means really is that the power is a negative index. Okay, so this is the reciprocal. So it's a negative index. So it means then that this would be 3 to the power of -2. Okay, because 3 squared is going to be 9, minus it, or minus index, is going to be 1/9. Okay, 3 to the power of b. Well, again, we've got to be a little bit careful with this, but as I mentioned before when we were looking at the part A, if you've got something like a square root, what we mean by that is 3 to the power of a half. Okay, so we could write this as 3 squared, which is 9, times 3 to the power of a half. So this is going to be 3b is going to be equal to 3 squared times 3 to the power of a half. So what it means then is we could write that as 3b is equal 3 to the power of 2.5. I'm going to leave it as a decimal at the moment just because it might make the calculation a little bit easier, but equally well I could write it as 5 over 2 if I wanted to. Okay, so the last one then is 3 to the power of c equals 1 over the square root of 3. Well, again, it's a negative index because it's the reciprocal. So actually, I could write that as 3 to the power of minus a half. Remember, the square root just means the index is a half. Okay, so if I want to then add a plus b plus c, what I'm doing is I'm adding minus 2 plus 2.5 plus 0.5. I'm going to leave it all in decimals today. Okay, so minus 2 plus 2.5 is going to be plus a half. Oh, sorry, this is minus, isn't it? I beg your pardon. Minus 0.5. So actually then the value is going to be equal to 0. Okay, so the value of a plus b plus c is 0. Okay, sorry about the little error there. That's a minus because it's a minus over here. I do apologize. Okay, so hopefully that was okay for you. Let's move on to question number 15. Now, the thing about this particular video, I want to try to aim for about 20 minutes per video. That'll give you at least an hour's worth of relatively focused revision if you stop the video and have a go at each of the questions. This one is going to be a little bit more challenging, so we'll see how we get on with time on this one. Okay, so what I tend to do with these is I tend to sketch them. I guess it's probably the way I was taught originally, but I just feel a little bit more comfortable by sketching the shapes. Okay, so let's have a look at this. So the surface shape of shape A, the surface area of shape A is 4 centimeters cubed. I'm just going to do a little cube, something like that. Okay, and we're going to call this one A. And what we do know about it is that we've got a 4 centimeters squared area. Okay, then I've got B. If you want, you can make it just a little bit bigger, I guess. It doesn't really matter. Okay, this is going to be B, and this is 25 centimeters squared. Okay, and then C, the ratio, the volume of shape B to the volume of shape C is going to be 27 to 64. Okay, well, all right, that's fine. Doesn't matter. So let's have a look at C. Okay, so this is going to be C. Okay, now in this particular case, what I'm going to do is I'm going to write that down as being 27 to 64. Now, remember, the volume is actually K cubed. Okay, so it's the scale factor cubed. Okay, so again, please do add a comment below if you're not sure about anything, or have a look on the channel, and there is quite a lot of work there on working with mathematically similar shapes. So this is a K cubed volume. Okay, now if I cube root each of those, I'm going to get the value of K, which is what I'm actually looking for. I think we'll have a look in a minute, but if I cube root each of them, I'm going to get 3 to 4, which is the value of K. Okay, that's between B and C. And I can do exactly the same with A and B, because A and B, this is the K squared term. So this is the area scale factor. If I want that to be the linear scale factor, i.e. K, I square root each of those, and I've got 2 to 5. Okay, so we're in position now where we've got the ratios between A and B are 2 to 5, linear ratio, so it's the ratio of heights, okay, linear. And then 3 to 4 for B to C, okay. And what they're asking us to do is work out the ratio of the height of shape A to the height of shape C, giving its answer in the simplest form. Well, the problem I've got here is at the moment I've got A to B to C, and I've got basically 2 to 5, and then I've got 3 to 4. Okay, so my problem immediately is that these aren't the same number. So what we have to do is make them the same number, and the way I'm going to do that is I'm going to multiply that and make it 15. Now, if I multiply that and make it 15, what I've done is I've taken this 5 and multiplied it by 3. So what I need to do then is I need to multiply this by 3 as well. So this is going to get multiplied by 3. So A and B are multiplied by 3 each. So that's going to be 6, okay? But then I've got this 3 here, which has been multiplied by 5 to get to B. So I need to multiply this one by 5, and that's going to give me 20. So what I've done now is I've evened up the ratios to make it kind of work for me. Okay, so hopefully you've been able to follow this. This is quite a complicated question, but hopefully you've been able to follow that one. Okay, what we're trying to do is make sure that B is kind of common to A and to C. Okay, so what we've got now is the ratio of the K factors, the vertical linear factors, which is absolutely fine what we're looking for. So the ratio of the height of shape A to the height of shape C is going to be 6 to 20. Okay, so A to C is going to be 6 to 20. Okay, in its simplest form, I just need to divide both sides by 2. So that's going to be 3 to 10 in its simplest form. Okay, so I hope that's okay for you. It will take a little bit of maybe stopping the video, having a go at it, working forward. So really all we've done with this is we've worked out the linear scale factors, and then we've simplified the ratio to make sure that we're using the same for each of those, the same multiplier for each of those. Okay, I hope that's all right for you. Please do add a comment below if you're not sure, and I'll try to point you towards another playlist. Okay, so number 16 is again one of those where you need a little bit of a technique with it. We are about 12 minutes into the video, so I think we've got a little bit of time to work through this one. And it's proved algebraically that 0.256 blah blah 5656 forever and a day is going to be written, or could be written, as a fraction. So the way you would do this, I think, is that you can multiply this by 100. Now, if you multiply it by 100, what I'm going to get is I'm going to move the decimal point 2 places. Okay, so what I'm going to say is let 100x, which is, this is x if you like, which I'll write in a minute, but well, let's write x. So x is going to be 0.2565656 ... Okay, that's fine. Happy with that, hopefully. Now, the objective really is to get rid of as much of this recurring decimal places after the decimal point as you possibly can. Okay, so if I multiply x by 100, I'm going to move the decimal point 2 places, and I'm going to get 25.56 beg your pardon, so 25, oh sorry, 65 65 65 65 and so on and so on. Now hopefully you can see that this from here on is one above the other. Okay, and what it means then is I can subtract those from each other and get rid of the recurring bit. And again, if you're not sure about any of these add a comment or have a look on the channel, and there are playlists on these recurring decimals. Okay, so if I subtract that now, what I end up with is going to be 100x take away x is going to give me 99x. And on this side, although I'm sorry I've written over the top of it, but I'm going to get 25.6565656 forever. Okay, take away 0.256656 forever. So this all disappears, and I get 26.6 take away 0.2 is 25.4. Sorry, I said 26.6, 25.6 take away 0.2, and I'm going to get 25.4. So what I've got now is a further value, which is 99x equals 25.4. So really it's just a case of manipulating this so it looks like this fraction. And the way I would do that is I divide both sides by 99, and I get rid of the 99 here. I get x equals 25.4 divided by 99. Now, changing that fraction to be looking like this, people will have different ways of doing it. Okay, the way I would do it personally is I would move the decimal point across, and that's going to give me 254 divided by 990. Now, what's going through my mind is that actually I can divide this through and this through by 3 if I wanted to, or actually I need to get it to be this. So it's actually a half. 127 is half of 254. So if I divide top and bottom by 2, I get, guess what, 127 over 495. And that's the answer to this particular question. Okay, I could have gone a bit further with that, I think. Possibly, I don't know, but hopefully it should be all right for you to at least answer the question in that particular way. Okay, so what are we on? About 16 minutes. So I think we'll give it another go for this next question. It's okay, this next one, but again, you're going to need some skills such as looking at things like completing the square to be able to kind of do this sort of question. So do please take your time, have a go at it. Okay, so it says the equation of a curve is that where a and b are integers or whole numbers. The point's 0, -5, which is this point. Okay, this is 0. 0 -5 is going to be here. Okay, and 5, 0, which is going to be here, lie on the curve. Okay, so we've immediately got some information that we can use, because what we're saying is if we look at this, we're saying that when x equals 0, y equals y equals -5. So if that's the case, then we can substitute this into the equation and figure out a value. Okay, so let's have a go at doing that. So what I'm going to say then is if we're looking at 0 -5, I can take that and plug it straight into this equation. So I'm going to get y equals x squared plus ax plus b. Okay, so -5, which is the value of y, equals 0 squared plus a times 0 plus b. Okay, well, hopefully you can see from there that 0 squared is going to be nothing, and a times nothing is also nothing, so therefore b must equal -5. Okay, so remember that what we can do, or what we're doing here, is we're working out the values that we can plug into this equation in order to then use that to find the turning points. Okay, so hopefully that's all right for you. Let's have a look then at what happens when we've got this secondary point, which is 5, 0. So I'll just try to kind of move this up a little bit so you can see it. So I'm going to have 5 and 0. So again, y equals x squared plus ax plus b. And what happens when I put then the value of x is 5 and the value of y is 0? So what I'm going to get is 0 equals 5 squared plus We're going to have A times 5. And then we know that B is minus 5. Okay, this is this value of B here. Okay, so let's start working that out. Well, 5 squared is going to give us 25, so 0 equals 25, plus 5A minus 5. Okay, so let's have a look then at where that will work out. Well, that's going to give you 0 equals 25 minus 5 is 20 plus 5A. Okay, move the 20 over to the other side. It's going to be minus 20. So minus 20 equals 5A. Divide through by 5. So now I know that minus 4 equals A. Okay, so hopefully now I can actually rewrite my equation because I've got my two values of A and B. And that's what I'm going to do. I'm going to write my equation as, rather than if I just put a line down here, y equals x squared plus ax plus b. Okay, well, I've got my values, so I can write that now as y equals x squared. Now, a is minus 4, so minus 4x, and b is minus 5. Now, if I want to then use that information in order to find the turning point, which is right at the very top of the screen there, it's this turning point here, okay, all I need to do is complete the square on that. Now, if you're not sure about completing the square, please do have a look at the channel and have a look at the playlist there, and that'll give you some good examples. But basically all we're doing is we're taking these first two terms and writing them as y equals x minus 2 squared. So we half this term, minus 2 squared. Now remember, what we're not doing is changing any values. Okay, or indeed we're not solving anything. All we're doing is we're taking this and we're writing it in a different way, the completed square form. Okay, so in my head, if I multiply this out, I get x squared minus 4x, which is perfect, no problem. Remember, this is x minus 2 times x minus 2. So the first two terms will be that. My problem I'm going to have is that when I multiply out the minus 2, I'm going to get plus 4. X minus 2 times x minus 2 is going to give me x squared minus 4x plus 4. So I've got to get rid of that. So therefore, I'm going to get minus 4 in there. Okay? So what I've now got is something that when I multiply out, I'm going to get those first two terms. That's great. The only thing I've got to deal with then is this minus 5. So I put this minus 5 on the end. Okay, so hopefully you're all right with that. So let's just tidy it up and then we can write out the turning point. So if we tidy that up, we're going to get y equals x minus 2 squared minus 4 minus 5 is minus 9. Now the big thing about completing the square is you can just read the turning point straight from it. So this minus 2 becomes a positive. Okay, so the turning point, I'll just write at the very bottom. Hopefully you can see this on the screen. So the turning point is going to be the opposite to this, the opposite sign is going to be 2 and then minus 9. Okay, that's it, really. So if we go back to the original graph, what it means is this point here is 2 minus 9. Okay, so I hope that's been okay for you. A little bit of a tricky one to finish off right at the very end, and I think also the one at question 15 was quite tricky as well. But that's 23 minutes into the video, so I think we'll leave it there. Please do add a comment below if you're not very sure about what we've done. Please don't hesitate to make contact, and I'll always try to support you as much as I can, and I'll look forward to seeing you inside the next video.